Now let us check the properties of scalar product. First property we'll discuss is scalar product is commutative. Now what does it mean? It means that if there are two vectors, which I call P and Q, in that case the dot product P dot Q is the same as Q dot P. Doesn't really depend on the order in which you take them. P dot Q is equal to Q dot P. That I am calling my first result here, and I'd like to give it some number. Let me number it equation number 7 for continuity, and the proof is quite easy to see here. Just see, I could write down P dot Q as the dot magnitude of P into magnitude of Q into cosine of the angle between the two vectors. I have seen it before. Similarly, if I started with Q, I could write down Q dot P is coming out to be magnitude of Q into magnitude of P into cosine of the angle between them. Obviously, it doesn't really make any difference here. If the vectors P and Q, they are like this, and the angle between them is phi, it doesn't really matter which way you measure the angle, it's coming out to be phi, the smaller angle between P and Q. And since it's a very simple thing of arithmetic, that you know that the product PQ, this is a product of two scalars, and QP are the same, like 2 into 3 or 3 into 2, both are 6. So you see, PQ and QP, they being the same thing, I conclude very easily that indeed P dot Q is equal to Q dot P. The order in which you take them doesn't make any difference in the value of the scalar product. You see by equation number 7. That's commutative property of scalar product. Next, property number 2. Now this is scalar product is not associative. Associative it is not. Let's see why. Let's write what it would be if associative it was. I should have been able to write in such case that P dot Q dot T. There are three vectors in question here, P, Q and T, and if it was associative, I should have been able to write P dot in bracket Q dot T and P dot Q, that product is done first, and then dot T. That I should have been able to write. Okay, now let's investigate that a little carefully. You see that Q dot T basically is a scalar quantity. The product of the scalar product of two vectors Q and T, this is a scalar quantity. So how can you have a dot product of a vector P and a scalar? You can't have a dot product of a vector and a scalar quantity. So it's useless, meaningless. Similarly here, P dot Q is a scalar quantity. And once it's a scalar quantity, you can't have a dot product with a third vector after that. This is also meaningless. So both terms are useless, they are meaningless, and hence associative property is not there in a scalar product. Third one that requires a little bit of understanding, that scalar product is distributive over addition. Distributive over addition. For the operation of addition, it is distributive. I shall exemplify that. So this is okay. Now what does it mean? It means that suppose we have got three vectors, and those vectors are named P, Q and T as usual. I'm just avoiding R and S for particular reason, because I have already said R I reserve for resultant and things like that. Let me see what it means, distributive property. It means that the vector P dot inside bracket Q plus T, the vector sum Q plus T in bracket, that if you open the bracket, this must be shown to be p vector dot q vector and then plus p vector dot t vector. Let's see the meaning of this. Here q plus t is a vector quantity, it's a vector sum, and that vector sum and p, we are finding out dot product of that. The scalar quantity it is. The whole thing is a scalar quantity because the dot product of p and the vector sum q plus t. Now, it should be able to be proved that. Now again, this is what? The dot product of p dot q, that's a scalar. And again, p dot t, that's a scalar. These two scalars must add up to give the result that's left hand side. That's once again a scalar. That is the meaning of distributive property of scalar product. We shall see this with a figure and understand it. See, I have this figure in my mind. This is a vector. Let it be vector p, and then I have q and t. I just join p and q at the tail, and then one more vector, that is t here, the starting from the tip of q. And let me draw also the resultant of q and t. I'll name it shortly, just wait it here. I said this is my p, this is my q, this is my t, and this is the q plus t, the red arrow, that is the vector sum q plus t. And I also draw perpendiculars from the tips of q and t as shown here. I name the vectors now. This was the point O common tail of p and q. Let me call this is the vector p, that I would call OA. The arrow OA represents vector p. And similarly, the vector, this arrow OB represents vector q, and BC represents my vector t. You just have a look at what we have to prove. This is the expression I have to prove it here. So OB is q, BC is t, joined end to end, and with the vector q we have got common tail, that is OA representing the vector p. And this is of course q plus t. This red arrow represents the vector sum by triangle law, and that is giving me q plus t, as you can see here. We also draw perpendiculars from the point B and C onto the line OA and call those perpendiculars respectively BD and CE. They are the two perpendiculars drawn on the line OA. Okay, so let's proceed. We could write here that P dot Q plus T. When I say that, I remember that graphical interpretation done a short time back that says that dot product of two vectors can be thought to be the magnitude of one vector and the magnitude or the component of the other vector along the first vector. So when I say P dot Q plus T, it means the magnitude of P, that is OA, into the magnitude of the projection, or rather the component of the vector q plus t along the vector p, that is coming out to be OE. See, once again, the projection or component of q plus t, this is one vector as a sum, this is inside the bracket, that is this red arrow, and the component of this red arrow q plus t along the vector p is given by the line, the length OE. So I could write P dot q plus t is coming out to be OA and OE product of that, right? Next, looking at the figure, I keep OA intact and break up OE into two parts because I can see OE is coming out to be the sum of OD plus DE. OD plus DE, that is my OE. So it's coming out OD plus DE. They are all scalar quantities, so I can break it up simply, and it's coming out to be OA into OD plus OA into DE. I repeat here, these dots are not standing for dot product. This is the dot product symbol dot. This is just to show we are multiplying to lengths. Each quantity here I have written so far, they are scalar quantities only. Now, Looking at the figure, what is OA into OD? OA is the magnitude of the vector P and OD is the component of the vector Q along the vector P. Similarly, we can see in OA into D, D is the component of the vector T along the vector P. So I'm getting here very quickly that the first thing, OA into OD, is coming out to be the dot product P dot Q, because I have said already that dot product of two vectors is given by the magnitude of one vector and the component of the other vector along the first vector. Here OA is the magnitude of P and OD is the magnitude of the component of Q along P. So OA OD is nothing but P dot Q. And similarly, since OA is the magnitude of vector P and D is the component of vector T along the vector P, I could also write down this is coming out to be P dot T. And that is the result we had in our mind. Been able to establish here that P dot Q plus T is nothing but P dot Q plus P dot T. We have shown graphically, and that proves distributive property of scalar product over addition. A final look at our findings on this page. We have found scalar product is commutative, that is P dot Q is equal to Q dot P. So I just approve of this. Then also distributive over addition, that is P dot Q plus T is equal to P dot Q plus P dot T. This is also perfectly all right, but it's not associative, which means this thing is of course not valid. There's no meaning of this expression.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.